We'll look at probability, and the first part of probability that we're going to discuss this day is on the axioms of probability, or the characteristics within which probability must hold. To start with, probability is simply the likelihood that an event will occur, the chances that an event will take place. Now, probability happens every day in our daily life, and probability is an utter chance that an event will come to pass. The number of axioms or characteristics that should hold for probability distributions in this regard. So firstly, we have this axiom which says the probability for an event should not exceed 0. This is an important axiom for which a sample space must hold, that you must not get anything above 1 or 100%. So this means that the sample space should never be 1.2 or 1.3, otherwise we would deem it to be an inexistent sample space. So the other probability is that when we're going to add all the probabilities, 1, 2, up to the last one, the sum total should always be equal to 1. We are also told that the probability must be greater than 0, meaning we can never have a negative probability. Then here, for mutually exclusive events, we need to understand that mutually exclusive events are events that have nothing in common. So for set A and set B, these are called disjoint sets. Number one, we need to understand that these disjoint sets have nothing in common. So the intersection set of A and B is 0. They don't meet anywhere. Then the union set of A and B is 1. When you add this plus that should give you 1. This is the rule that holds on disjoint sets. The term O means addition. So when you say probability of E or F, it means you add the probability of E to the probability of F. So this is what we mean. Then later on, we need to understand that probability of an empty set is as good as 0. So if the probability of two disjoint sets is empty, it means there is nothing in common. Then A is a subset of B, is denoted by this symbol. So in short, from the axioms we've discussed that the probability must range between 1 and 0. Between 1 and 0. So we can never get anything more than 1 or less than 0. So this axiom is really important. So I'll quickly take you also to what we call the complement rule. The complement rule simply says that A complement is the same as not A. A complement is the same as what is not A. What is not A is the same as subtracting it from 1. So if A is 20%, what is not A is 80%. So the complement of A is 80%. So to find A, it is 1 minus A itself. So 1 minus 20% gives you 80%. So this is what we call the complement rule. In short, adding A and its complement should always give you 1. We also have one important formula under the axiom, which is a union set formula. A union B is simply equal to the probability of A plus probability of B. You subtract A and B. We know that AND stands for intersection. So we're going to graphically show this in a table. So if you want to find the probability of A union B using De Morgan's rules, it means you need to add what A has and add what B has, you subtract what they have in common, because you end up duplicating their addition. So it's A plus B minus the intersection. So today I'll dominate on 4 key axioms of probability. 4 key axioms of probability. So these probability axioms will help you answer key questions. Number 1, that the probability must range between 0 and 1. Number 2, that the probability of A union B is equal to probability of A plus probability of B minus the intersection set. So when we make A intersection set, subject here, it will be positive, and this one, when it goes this side, it will be negative. So this is what becomes the formula for A intersection B. Then the rule of complements, A minus A, 1 minus A is equal to the complement of A. Then we go to this important rule, which is called Bayes' theorem. Bayes' theorem. So under Bayes' theorem, we say A given B, the slash there is read as given. A given B, the B will go down there, then you intersect the two letters A and B. So this will be A intersection B. We usually start with the letter that comes first in the alphabet. So B given A, the A will come down there, then we're going to have A intersection B on top. So this is the most important rule or formula that you need to take note of. Then we have Theorem 2, which says A is simply when you add A and B intersection, but if there's A here, the complement will be on B. B is also equal to A intersection B, but when there's B subject there, the complement will be on the other letter, which is A. So this is what we call Theorem 2. This is what we call Theorem 2. There's also Theorem 1, where you simply multiply probability of A times probability of B to get the intersection. The intersection set has 5 key formulas, so you need to know when to use the intersection set formula. Then we have these conditions of independence. A given B must be equal to A. B given A must be equal to B. You maintain the top letter here regardless of the letter that is down there. So A given Z is still A. A given R is still A. Doreen Kaseva given Sata is still Doreen Kaseva. Doreen Kaseva given Wanawasa is still Doreen Kaseva. Doctors maintain their names regardless of who marries them. So regardless of what letter is down there, you maintain the top guy. Even if there was X given A, it will still be X. That is what it means to be independent. If the intersection A and B is 0, it means they're mutually exclusive. Theorem 1, I said when you multiply A and B, you get the intersection of A and B. This is when you're not given other rules. So quickly, using Bayes' theorem, we have discussed 5 key formulas. So I need you to now take me through. You are 4 of you. Give me the 4 formulas that you got, just to cement on what we did. All right. What did I say? A given B is, somebody to lead us. What is A given B? Which letter goes down?
A given B would be P open brackets A intersection B over probability B.
Great. Then what becomes the opposite? What is B given A?
B given A would be probability B intersection probability A intersection B over probability A.
Excellent. Over probability of A. So the bottom guy goes down. All right. Next, who's leading us into giving us a union set formula? Somebody else? Who's giving us a union set formula A union B? Langiwe.
I've just joined, so I'm trying to catch up where you are.
Okay. Sibu.
I've just joined, so I found you winding up on there. I'm trying to just ish.
Sibu, what is the probability expansion of A union B?
Probability of A plus probability of B minus probability of A and B.
A intersection B.
Yes.
Okay, great, that's correct. Okay, somebody to help us find the complement of A. Somebody else, what is the complement of A? Patricia, A. Simply 1 minus A itself. So what's the complement of B? Simply 1 minus B itself.
Is it 1 minus B? Yeah.
Okay. What is the probability of of A using theorem 2? What is the probability of A and B using theorem 2? It is the intersection of A and B plus A and B, but where would the complement be?
On B.
On the other letter, good, B. All right. How about here? The probability of B will be the intersection of what? A and B and A and B. And what would the complement, where would the complement be? On which letter would the complement be?
On A.
On A. Okay, so this is what we discussed so far. And we also said for us to know that A and B are independent, A given B must be equal to what? Must be equal to what? And B given A must be equal to what? For them to be independent. A and B must be equal to what? And B given A must be equal to what? Who remembers? How do we know A and B are independent? Yes, Sibu. A given B must be equal to what? I said Doreen Kaseva. Given Sata must be Doreen Kaseva. So whatever letter is down there, you maintain the top guy. Here we're going to put letter A. How about here? B given A must be equal to what?
B.
B.
Must be equal to B. Good. This is if they're independent. How about if they're mutually exclusive? What is the rule for mutually exclusive? A intersection B must be equal to what? For us to know that these are mutually exclusive, The intersection of A and B must be equal to what? Who remembers?
Is it 0?
Yes, 0. Or empty set. If you have nothing in common, then you are mutually exclusive.
Yes.
Remember? Or something like this means that you are mutually exclusive. So these are very key and important. So we will do an example together. Probability of A is 0.4. Probability of B is 0.3. Probability of B is 0.3, and probability of A given B is 0.4. So I need each one of you to choose any one of them. Let's start with the intersection set. How do we find the intersection set? A, find probability of A intersection B. So for us to find A intersection B, we need to expand this conditional probability A given B. Who remembers how to expand A given B? Who remembers A given B? Let's expand it.
It's a probability A intersection B divided by probability A.
Is she right? Is she correct?
Ah,
Divided by what? Is it A or B?
It's B.
Divided by the bottom guy, B, right?
oh, divided by B, sorry.
Okay. So it's divided by B. So this is very important. So once you mix it up, it thwarts your answer. So we'll now substitute
Yeah.
where there's A given B, we're going to put what? 0.4. Where we have A intersection B, we don't know. Where probability of B and given 0. What? 0.3. So we cross multiply. 1 times A intersection B is A intersection B. Then we multiply 0. What? 0.4 times 0.3. What do we get? 0. What? 12. Okay, so I have started the first one for you. So somebody else to lead us in the probability of A union B. Who wants to take us through A union B? Somebody to take us through A union B. What is the formula for A union B?
Probability of A plus probability of B minus probability of A.
Excellent. So what is probability of A? What's probability of B? And what is our intersection set?
4,
Our A was 0.4, and our B,
0.3,
and B was 0.3, and our intersection,
0.1.
we just found 0.12. So what becomes the final answer?
Zero point 0.58.
0.58, correct. Okay. So if you get the intersection wrong, you also get the union set wrong. Somebody else who wants to lead us into the complement of A and the complement of B. These ones are easy. Complement of A and complement of B. Anyone? What is the complement of A? Complement means what is not A. So what is not A is simply 1 minus A itself. Yes, Mia?
I wanted to say 1 minus A, it's fine.
So what becomes the answer? What is 1 minus A? 0.6, isn't it? And what is 1 minus B?
0.7.
0.7. Good. Okay, then now we're going to find the complement on A intersection B and the complement on B intersection A. So this is theorem what? 2. So we need to find these two here. So to find these two, we need to understand the probability of theorem 2. Who remembers? Who can expand this? What is the probability of A? Somebody quickly. It is A intersection B plus A intersection B, that the complement will be where? The complement is will be on which letter? The other letter, right? So what was our probability of A? 0.4. What is the probability complement on B? That's what we're looking for. What is the probability of the intersection set? We found 0.12. So how do we make the subject of the formula complement on B? What becomes the probability of A intersection B? We'll subtract 0.4 minus what? This one goes subtract there. 0.4 minus 0.12, isn't it? So what becomes our final answer? 0. What?
28. Is it?
28, yes. So far at this point, anyone behind? So we have found this as 0.28. So we now need to find this one here. So if the complement is on A, so meaning the subject of formula must be what? must be B. So B is equal to A intersection B, A intersection B. Complement here will be on the other letter. Which letter?
Is it on A?
On
A.
Good. So what's the probability of B? 0.3. And we're looking for this part here, complement on A. But we have the intersection of A and B. Yes, so 0. What? 1, 2. So how do we make, what becomes this one? When it goes subtract there, what are we going to have?
Mm. 0.3 minus that. 0.18. Okay.
0.18. So far, are we together?
Almost.
All right. Then the examiner will now ask us, find the probability of A given B, and find the probability of B given A. So let's try this. Who wants to help on the first one? How to expand A given B? It is A intersection what? B
Intersection B
over
over probability B.
probability of B. Good. How about this one? B given A.
A intersection B
Mm-hmm.
over probability A.
Good. So here it's a A that goes down. Here it's a B that goes down. So what do we get? A intersection B here? 0.12, which we found. And the probability of B was what? 0.3. Here it was 0.12, and the probability of A was what? 0.4.
0.4.
So what are we getting here? Zero 0.3, and there it's 0.4. Okay. Then we go to the conditions. Are they mutually exclusive? Who remembers the condition for mutually exclusive? Are they mutually exclusive? How do we know they're mutually exclusive?
The intersection is 0.
Good. If the intersection is 0. So step 1, state the condition. The condition for mutually exclusive must be that the intersection must be 0. So step 1, state the condition. Step 2, compare the figures. What was our A intersection B? 0.12. Is it the same as 0? No, not the same. Then conclude. Therefore, it's not what? Mutually exclusive. Unless we found our intersection as 0, we'd have said yes, they are what? Mutually exclusive. Who remembers for independence? What is the condition? A given B must be equal to what? Who remembers the condition for independence? Probability of A given B must be equal to what? Must be equal to?
Probability.
Yes. Must be equal to the probability of A, the top guy. So step 1, compare the figures. State the condition, sorry. Then compare the figures. What was A given B? 0.4. And our B was what? 0. Our A, sorry, was what? 0.4. So are they the same? Yes. So you can also say yes, they're independent. A and B are what? Independent. So this is how we look at the condition of probability. So copy this homework. Suppose A is 0.3, B is 0.4, and instead of A given B, now you're given B given A is 0.5. You will be asked to find the probability of A, all the probabilities you found. A intersection B, find A union B, find the complement of A, find the complement of B, okay, that's part A. Part B, find the intersection complement on A, intersection B, find the complement on B, intersection A, find probability of A given B, then also are they independent or mutually exclusive? Or neither? Are events independent or mutually exclusive? Or neither? Okay, please don't embarrass me. Do your homework very well. Ask your husbands where you're stuck, or follow this video I'll send you religiously.
Really? Can you imagine this, Colin? How do you know the husband we can even do this?
Just give him the video to listen to.
Husband, there is no.
Husbands, there is no. Yeah. So I am simplifying this as much as I can. Right? I know you've been busy during the week. We did quite a number with the other group. So before I look at the assignment questions, I need you to understand the basic way. Once you get this, then we're good to go. So
Okay.
the other part is on the contingency table. So part A Question 1 is mine. Question 2 is your homework. So whatever I do at part A is what you do at question 2. Here I have A, B there, X, and Y here. A, Y, B, X. So we have 2, 4, 6, 8. 3, 6, 9, 12. Okay, so we've been asked to find A, probability of A, probability of B, probability of X, the probability of Y. And part B, we've been asked to find the probability of A given B, and B given A. Can copy what I'm writing, and X given Y, and Y given X. And finally, C, it asked to find A and B, probability of A and B, and the probability of A or B, and probability of X and Y, and probability of Y or X. And finally, part D, are they independent or mutually exclusive? You can deduce independence or mutual exclusiveness. Deduce if they're independent or mutually exclusive. Okay. So the first thing you need to do when you're given a contingency table is to find the totals. What is the total here? The total here, the column totals and the overall total. So here we have what? 6. And here we have 14. Here what do we have? 8. And here we have what?
12.
12. And the total of totals is what? 20. This is a grand total. So far, are we okay in summing up the totals?
Yes.
Yes.
Yeah.
All right. So now to find the probabilities of each of them, probability of A is 6 over 20. It's simply the total of A over the grand total. Probability of B, 8 over 20. X, 14 over 20. Y, that's the probability of Y.
12 over 20.
20.
12 over 20, correct. You can reduce them in decimal points later on, okay? So it is clear to find the totals of each. You just keep the raw total over the grand total. Anyone lost on that?
Sorry, kindly go over that again. I was a bit disturbed.
Okay, the total for B is 8, 12, 6, and 14. Then it's a grand total. So to find the probability of A, so the probability of A is simply the number of elements that you have in A over the total sample space. We have the grand total. Number of elements we have over S. So how many elements do you have in A? We check on the totals for A. So when we go to A, the total for A is what? 6. And the grand total is 20. So here you're going to write 6 out of 20, which is 0.3. So it therefore follows by the probability of B is 8 out of 20. X is 14 out of 20, and Y is 12 out of 20. Is that clear? This is how we found that.
All right. Thank you.
Then the probability of A given B so we've done the probability of A. So the probability of B likewise is the same as what? The total for B, which was what? 8 over 20. 8 divided by 20, which is in decimal point 0.4. So probability of A given B, we know how to expand this. This probability of A intersection B over probability of B. So probability of A intersection B is where they meet. A and B, where do they meet? You go here, you draw a plus. A and B, they meet at 2 over the grand total. So 2 out of 20. 2 out of 20. And probability of B, we already found it 0.4 or 8 out of 20. This and this cancels, so simply going to have 8 out of 20, or 2 out of 8, sorry, which is a quarter. Which is 0.25. Now, I'll teach you a shortcut since mature you love things that make them the lives easy. So A given B, kumuna fepo wale kumana A and B, and the total for the bottom guy. So A and B are meeting at what? At 2. But the total for the bottom guy, the B, the total for B is what? 8. So just write 2 over 8. So A upper 2 over 8. So you go where they meet A and B, they meet at 2. But the total for B, which is 8. So 2 over 8 is 0.25. So let's try together. B given A, the shortcut. Where do we look? Where do we go first? Where they meet B and A. Eh? Where they meet B and A, where do they meet? SM2. So B,
SM2.
but the total for which one now? B given A, the total for which letter?
For
the bottom one, it's fine for A, which is what?
or A, which should be 6.
Yes, so they meet at 2. So 2 over what? 2 over 6. Okay. Okay, let's try X given Y. X given Y. Where do we go? X given Y. Where do we go? Where they meet?
Where they meet.
X and Y, they meet where?
At 8.
At 8, good. But the total for which letter?
Or Y.
Which is what?
Which is 12.
So the answer will be what?
Or Y, which is 12.
Yes, the answer will be 8 over what? 12, isn't it? So it'll
8
be
over 12.
8 over 12. So this is 8 over 12. So the opposite, y given x, the 2 meet at 8, at the total for x this time. So it will be 8 over what? 14. Is that clear? Y given x, they still meet at what? Same 8, but the total for x, which is 14. Then A and B, and means intersection. So where they meet, A and B, but over the grand total. A and means what? Intersection. Or means what? Union. So you need to understand this. And means intersection. It also means multiplying. So A intersection B, where they meet A and B, they meet at 2. But the total of everything, 2 out of what? 20.
20.
Okay. Meaning what becomes X and B? What becomes X and B? And means what?
Intersection.
Yes. So it will be X intersection what?
Intersection Y.
Y.
Intersection Y.
Okay. This is 0 point what? 0 0.1. Okay. So where do they meet X and Y? We go back here. Where do they meet?
That's 8.
8. But the total for which one? For everything. So 8
For,
over what?
for
20,
over
right?
12, is it?
Yes. 8 over 20, which is 0 0.4. Okay. Then they are now asking for A or B. A or B. O means what? Union, right? Can somebody remember how do we expand A union B? Probability of A plus what? Probability of B minus what? A intersection what? B. So what was the probability of A? What was the probability of A? We found probability of A as 0
0.3.
and probability of
0
B
0.3. 0 0.4.
and the intersection 0 0.1.
Yeah, 0.1.
So 0 0.3 plus 0 0.4 minus 0 0.1. What do we get?
Yeah.
Okay.
0.6.
Anyone behind so far? Okay, so what is X or Y? It's the same as what? Or means what? Union.
Union.
So probability of X union Y will be what? Probability of X plus what? Plus probability of Y minus what? x intersection y.
Y, X intersection Y.
Yeah. All right. Just by looking at the table, what's the probability of x? (14/20). Y, 12/20. X is 14/20. Y is 12/20. The intersection of x and y is what? 8/20. So it's 14/20 plus 12/20 minus 8/20. Okay. So 14/20 plus what? 12/20 minus what?
8/20.
8/20. Which will give us what? 18/20. Which is 0. What? Which is 0.9. So that is the probability of x or y. Are events A and B mutually exclusive? No, since we got our intersection as what? 0.1, it must be 0. How about x and y, are they mutually exclusive? No. We got 8/20, which is 0.4. They're not mutually exclusive. Are they independent, x and y? Or and A and B? We need to compare. A given B must go to A. So here we found 0.3, and here we found 0. Can you hear me?
Yeah.
Can you get me?
Yes, we're still here.
Yes.
Okay. So they're not independent, they're also not mutually exclusive. So this is where we will end our session for today. I will save these notes as well. Unless you have any questions from what we have learned today, please ask or forever hold your peace. Any questions from what we have done? Please ask now or forever hold your peace.
I just want to look at question 2. I didn't take note of it.
Question 2. Okay. Here, this is question 2.
I just wanted you to maybe go through again. Where do we determine for us to say over the total, like the
Intersections.
14/20?
So the intersection set is the only one that will give you over the total. So A intersection B, it will be 2 out of the total 20. X intersection Y, it is 8 out of the 20 total. But if you're being asked A given B, the given should be the total. So it's A given B, so 2 out of 8. The letter which is down there should be the total itself. B given A, where the meeting is still at 2, but the total for the bottom guy or the bottom character. But if it's just saying intersection, you find where the meeting, but the total for everything. That is what we are supposed to do. All right.
Okay, thanks.
Yeah. Any other questions? Any other questions? Okay, so I'll end here. I'll send you the recording.